All right, 6.3b, vectors in a plane. All right, all the stuff that we've learned in mathematics up until this point will still hold true. Just like number one, commutative property still happens. Associative still happens. At zero, hey, it's identity. It still happens. Inverses property still happens. All right, so all the stuff that you've learned in mathematical procedures, they are still okay. All right, we need to talk about what a unit vector is, and we talked about it a little bit yesterday. What is a unit vector? The magnitude is 1. Exactly. All right, and this is how we actually find a unit vector. A unit vector, we put our vector, whatever it is, over its magnitude. So a unit vector, we put the vector over the magnitude. And what it means is that it's still going to go in the same direction, because a vector has direction and magnitude. Oh, yeah. It's still going to go in the same direction. However, it's going to be shorter. It's going to be a magnitude of 1. In most cases, it's going to be shorter. I guess you could have a little vector, but in most cases, we reduce that size. All right? Angela's going to read for us.
Find the unit vector in the direction of v equals -2, 5, and verify that the result has a magnitude of 1.
All right. So we need to have a vector that goes in this direction, but only goes out 1. And so we need to basically strip its magnitude from it. All right, so we need to put its vector v, over the magnitude of vector v. And so we have -2, 5, okay, inside the angle brackets, inside the chevrons, to show that it's in a component form of a vector. And then we need to put it over its magnitude. Well, how do we find its magnitude? The distance formula. So we have square root of 2 squared plus 5 squared. All right. 2 squared is 4. 5 squared is 5. We add them together. We get square root of 29. So our last step is now we have -2, 5 inside my angle brackets over square root 29. So now we have to distribute our dividing, or really multiplying by 1 over square root 29. So now our unit vector would happen to be -2 over square root 29, comma, 5 over square root 29. And so that is my unit vector of that problem. Okay, so now that would actually have a magnitude of 1. All right. Pretty good? How do we find a vector? Unit vector, it's what? Vector over its magnitude. So before we talked about things in what's called component form. And component form was in these little chevrons or these angle brackets, remember? And so what was in this first part had to do with like the x part. It moved left and right, correct? And then what had to do in that second part kind of had the y value. It moved up and down. Now we're going to talk about what's called a linear combination form. Please write that on your little notes. Now we're going to talk about a linear combination form. And what that means is now they're going to have I hats and j hats. Now, most books denote it by a boldface I and a boldface j. However, it's really hard to make a boldface something on your paper. So the way that we take care of it is we have I hats and j hats. All right? If you take Calc 3, you're going to end up getting a k hat as well. Now, why do you think they have these little arrows? But what does it represent? It represents an arrow, which represents a vector. Vector. All right? A vector. So our I hat is basically like, hey, that's the x component of it. The I hats move left and right. Does that make sense?
Yes.
All right? And the j hats, guess what they do?
Up and down.
They move up and down. So if I had something like, I don't know, let's say 2 I hat minus 3 j hat. I don't know. 2 I hat minus 3 j hat. What did that vector do? It moved right 2 and down 3. All right, that's what that vector did. And so that vector would actually just be in component form of 2 comma negative 3. Those two things mean the same thing, okay? It's just different ways of writing it. That we have u is equal to 2 I hat minus j hat, and v is equal to negative I hat plus 3 j hat. And I need to find the vector u minus v, okay? And so what I'm going to do is I'm going to just graph it. Okay, and you're going to be asked to do this. So my u does what? Which way does it go? Right 2 and down 1. So I'm going to go right 2, and then I'm going to go down 1. So my u, my vector u, does that. Does everybody understand that? Okay, it's just our different form of it. And then I'm going to say minus v. I'm going to say minus v. Well, normally v goes left 1 and up 3. However, if it's subtracting it, which way are we going to go?
Right one.
We're going to go right 1
Up two.
and
Up two.
up 3. Up 3, right? No, down 3. Down 3. Dear goodness. Right 1 and down 3. All right, so right 1 and down 3. And so there's my negative v. Okay? And so then we draw our resultant vector right there, and then we'd have u minus v. Okay? And so if we do this just by math, we'd have 2I hat minus j hat, and then we'd have minus negative I hat plus 3j hat, right? And so I'd end up having what? I'd have how many I hats? No. If I'm subtracting a negative, I'd have 3 I hats. And then negative j hat, and then minus 3j hat would be negative 4j hat. So I should end up at 3 to the right and 4 down. You see how that worked? Okay? So it's just like before, but now they're just with I hats and j hats. Okay? All right.
Let u be the vector with initial point 2, comma negative 5, and terminal point negative 1, 3. Write u as a linear combination of the standard unit vectors I and j.
All right. So now this tells me to write it in what? A linear combination. Okay? And that means with what? I hats and j hats. Okay? It tells me I'm going to write vector u. But before, how do we find a vector? It's always what? Terminal minus the initial. Okay? It's always terminal minus the initial. So my terminal is what? Negative 1. Now I'm subtracting what? 2. So what do I get there? I get negative 3. So I have negative 3 I hat. All right. And then my j hat component would be what? 3 minus a negative 5, which is 8. So plus 8 j hat. All right. So which way did it move? Left 3 and up 8. All right. Here we go. Write it out. So now I have u is equal to negative 3 I hat plus 8 j hat. Huh, look at that. We did that one. And then v is equal to 2 I hat minus j hat. And I'm going to find 2u minus 3v. So we're going to go back to 7th grade and see if we can distribute and combine. So now I have 2 times negative 3 I hat plus 8 j hat. And then minus 3 times 2 I hat minus j hat. So guess what we need to do? Distribute. So when I multiply by 2, now I have negative 6 I hat plus 16j hat. And then minus 6 I hat and plus 3j hat. So now I need to combine like terms. So how many I hats do I end up with? Negative 12 I hats and 19 j hats. What did the resultant vector do? Left 12 and up 19. All right, well, left 12 and up 19. You try. Help me out for part A.
Write the vector 5, negative 8 in terms of I and j, so you just put like 5i and negative 8j.
5 I hat minus 8 j hat. Good job. Calling somebody.
Evan.
Evan, help me out.
What is it? Once you multiply them or distribute them, you get 6 I hat plus 4 j hat minus 5 I hat plus 3 j hat, and then you get I hat plus 34 j hat.
Then we end up with I hat plus 34 j hat. All right. Are we good? All right. Fantastic. More problem. I want to do one more problem with you before I set you free. So what kind of magnitude do we want? Pick a one-digit number. What? 8. 8. So we have a magnitude of 8. All right. Zach, help me pick my vector then. What do you want my vector to be? I'd pick one-digit numbers if I were you. -3, comma 5. Love it. All right. So what we're going to do is we're going to find a vector that has a magnitude of 8 and a direction of -3, 5. All right. Because right now this -3, 5 also has a what on it? Because a vector always has a what? A direction and a magnitude. Well, all I want is the direction of it. So what do I have to do to this vector to just have a direction on it? I have to strip away its magnitude. How do I do that? Make it a unit vector. All right. So the first thing we're going to do is we're going to find a unit vector of -3, comma 5. All right. So how do we find its unit vector? We do a vector over its magnitude. So now, how do we find its magnitude? Square root of 3 squared plus 5 squared. All right. And so we end up with square root of 34. Good. So we have -3, comma, or -3 over square root of 34, comma. Then we have 5 over square root of 34. And so right now, this is my unit vector. And so it's really only going out a unit of 1, but I want it to go out a unit of 8. All right? And so all we have to do at the end is we just multiply it on. So now we have 8 times -3 over square root 34, comma 5 over square root 34. So we end up with 8 times -3 is -24 over square root 34, comma 40 over square root 34. And so this vector now has a direction that's the same as -3, 5, and it has a magnitude of 8. All right? Pretty good? So when we do that, we have to find its what?
Units.
Unit vector, and then we multiply it by the magnitude that's given. Okay? Worksheet 6.3b.